So I wanted to go back because this is where my other class stopped or where it cut off. So, all right, so lipids, long chains of hydrocarbons. Again, that's a long chain of just hydrogen and carbon, and water does not mix with that because it's perfectly stable, covalent. Remember, water only dissolves things that are either polar covalent or what? Ionic. All right, so what I said was it's a high energy storage molecule, which is a good thing. Usually you think of, oh, but things that are high in fat are high in calories. That's true, but what technically a calorie is it's the measure of the amount of energy that food can give you. So if you want to store energy, storing it as fat is the best way to do it because you can store double the energy in half the space. So if you think about the fat on your body, you would be twice the size you are if you had to store the energy as starch instead. We'd all look like big baked potatoes. So we can store a lot of energy in a small amount of space, and so that's where the lipids are important for energy storage. It allows us to be much more compact. Did you have a question?
If calories are energy, why are calories bad for you?
They're not bad for you. The problem is that, well, particularly as Americans, we have a taste for high-calorie foods, and they are energy, but your body's not going to use all the energy. If you eat more energy than you need, your body's going to store it. That's the problem. So like when I get my extra mega large McDonald's shake that has 1,500 calories in it, my body really doesn't need all those calories. So that's where you're gonna store it as fat. So calories are a good thing. It's just the problem is we tend to eat way more calories than we need because we like the taste of food, and we've learned to make all kinds of foods that are just super high calorie.
So if you eat like one thing all day and it's really unhealthy, like shakes, it's just like 15,000 or whatever, 1,500 calories of bad food, your body burns all of it?
Yes.
So then it's not bad for you, really?
Yeah, well, that's a
How
good
does that
point.
work? Yeah.
Here's the thing. She was saying, what if I eat the 1,500 calorie shake and I eat it in the morning and I don't eat anything else all day? Technically, I'm not eating too many calories. Technically, in fact, I would lose weight because that's less calories than I need. The problem is there's other things you need besides calories. Your body also needs calcium. Your body, although shakes probably have calcium, you get away with that one. But your body needs potassium and magnesium and vitamin A and vitamin C. And so when you're eating, if I ate a 3-pound bag of M&Ms and I ate nothing else, calorie-wise, I'd probably be okay. I probably would lose weight, but I'd also probably end up with scurvy and all these other diseases that are vitamin deficiency-related diseases because I'm eating just carbs and nothing else. So that's the problem. But yes, losing weight-wise, I would definitely go on the shake diet. That sounds very good. All right, fats and oils are our most common lipids that everybody hears about. We also call them triglycerides. Tri for 3, and it's 3 fatty acids. And here's a little diagram of what triglycerides look like. Whoops, let me bring that back. I don't know how well you can see that. Again, the TV was better than this. But so this is triglycerides. Here's your long chain. Oops, hold on. Here we go. Here's your long chain of fatty acids. Here's a second long chain of fatty acid, and a third long chain of fatty acid. And then this little 3-carbon thing, this is the glycerol. And so that's why it's a triglyceride, 3 fatty acid chains and a glycerol. This one down here, you may notice, is all bent. It's not because they ran out of space, you know, like when you run out of space for your notes, so you turn to the side and you scribble. That's not why that's bent. It's bent on purpose. So I'll show you on the next slide why that is. But I don't want to go too fast. Everybody got that? Triglycerides, 3 fatty acids, and a glycerol.
Yeah.
All right, perfecto. So here's a diagram to show you the difference, or this is going to explain the difference. What does it mean if I have a sponge and I tell you the sponge is saturated with water? It means it's like as full as it can possibly be, like it can't hold another drop. Well, lipids can either be saturated or unsaturated. And the book usually gives the explanation that saturated have single bonds and that unsaturated have some double bonds. But that doesn't really explain to you why they're called saturated. The reason they're called saturated is because this would be a saturated fat. It would be a long chain of carbons, like this, and it would be saturated with hydrogens. In other words, every carbon would have as many hydrogens as it could possibly hold in the carbon chain. So this right here would be an example of a saturated fatty acid.
Yeah.
Now it would be called a fatty acid because at the very end, and don't confuse this, this is a double bond, but This is not part of the chain. This is the acid part of a fatty acid where it would connect to make a triglyceride. So every single bond, there's a single bond. What it really means, though, by saturated is this is holding as many hydrogens as it can possibly hold. It's saturated with hydrogens. And so that is a saturated fat. And it turns out, and I'm going to explain why in a second, that saturated fats are typically solids at room temperature. So when you think of like if you cook bacon and then you leave the pan there and the like lard gets all nasty, and that's basically a saturated fat. Plants generally make only unsaturated fats. Plants don't make saturated fats. Animals do. Butter. Butter's saturated, but oil is unsaturated. Butter comes from cow's milk, an animal product. Oils tend to be corn oil, olive oil, peanut oil. Yes?
What about like Crisco, like shortening? Oh boy.
That's a good question. Actually, I want to explain that.
Because it does not have vegetable oil?
So actually, going back to Crisco and also margarine, here's the thing. Crisco is actually made out of vegetable oil. So you're like, well, how do they get it to be solid? What they do is they actually put it through a process called hydrogenation. Literally, they take it because it doesn't, it normally is unsaturated. In fact, so let me show you a picture here showing the difference. So here's your saturated on the top and unsaturated. So here's an unsaturated oil. Let's say this is corn oil. And what they do is they put it through a machine that literally pumps a bunch of hydrogens in. And it kind of semi-saturates it. And now, because it's semi-saturated, it can actually start to form a solid. Now, the problem is, and this is what they didn't discover until very recently, is that they said, okay, you know what we're going to do? We're going to make partially hydrogenated vegetable oil. That's what they call it, partially hydrogenated vegetable oil. So it's vegetable oil, but they've pumped these hydrogens in to sort of turn it into a saturated fat, but not completely, so that it would still be better for you. What they didn't know is, when they pumped the hydrogens in, it got a different shape called a trans fat. I don't know if you've ever seen on stuff all today, they all say no trans fats. People made trans fats. They're not natural. It came from people taking unsaturated fats and saying, you know what, we're going to, instead of giving you lard, we're going to make Crisco. We're going to take this, which is better for you, we're going to pump hydrogen in and turn it into a solid, so it's sort of fake fat, but it still will be better for you. It turned out they made something that was worse for you, because they actually, when they pumped the hydrogens in, changed its shape so that it was even worse than a saturated fat. Just another example of what we don't know. So today we've come up with methods of doing this so that we don't make trans fats. And but that's the difference. Now, why are unsaturated liquids? And why are they better for you? Why do they stay liquids in your system? Well, it's because of these little bins. Like we call them kinks. Think of unsaturated fats are kinky. Because what's happening is, I know, that's an easy way to remember it. The boys will remember it. All right. So let's say these are saturated fats. They're nice and straight. So what happens is, as the temperature goes down to room temperature, since these are all nice and straight, they can stack and congeal into a solid really easily. Now, when you think of an unsaturated fat, everywhere there's a double bond, and some of them have lots of double bonds, they're kinky. Like if I take this and I crumple it, which I really don't want to do, this is my seating chart. But if I take a bunch of crumpled ones and I stack them, they're not going to flatten out and congeal really easily. You're going to have to drop the temperature much, much lower to make that turn into a solid. So unsaturated fats are liquids at room temperature. They stay liquids in your body. A lot of them have special jobs that help you. Like you hear about like omega-3 fatty acids now. There's specific oils that have specific jobs that help you. So saturated fats are more likely to get stuck in your blood vessels and form plaques and lead to heart disease and things like that because they can form solids so easily. The kinks in this actually keep them moving and make them better for you. So does that make sense, the difference? The last slide. Actually, you know what? I'm going to stop there because I promised you you'd have time to work. So thank my son for slowing us down. So, yes.
Where do I